All right, I'd like to welcome everyone out. Thanks for coming here. I am very enthusiastic about system infrastructure, network infrastructure. I have lifelong experience and love with communications and networking and putting things together. And so I'm really enthusiastic. This is kind of go how to build. I realized I'd been kind of worked for telecom for the last decade, and I hadn't realized that most people were using public infrastructure. I know, like I've used Firebase and AWS and Azure and all these different things to a limited extent, but I didn't realize that people were using them primarily, even for kind of hobby things, right? They didn't have their node or machine in their house, and so yeah. So I didn't realize that, and so this is kind of a way to get people off Squarespace and decentralize even without blockchain. You don't need blockchain to decentralize anything and to become knowledgeable and aware of the technology around. Kind of wrap around any of you confidentiality, integrity, and availability. That's kind of the trifecta of systems or services. You kind of want to maintain all three. Any of you that have ever done CISSP or any certifications like that, that's kind of one of the points. Whether it's AWS or GCE or Azure or DigitalOcean, that's something they're shooting for on that. You want things to be secure, we'll kind of go over that. Ease of management and maintenance. Everyone has limited time. Time is a limited resource, so you want to do things more intelligently. A lot of the large clouding compute have done this. You can do it at home as well. There's very good open source projects that do it. The thing I always laugh at is Amazon took open source projects that they use for their own thing, and they sold it, right? They sold it, and a lot of people pay a lot of money for that. And I didn't realize, I hadn't really, the last year I kind of helped some friends on it, and I didn't realize how costly it was until I looked at their billing for what they were doing. And it's just, I mean, I was a kid, like you could do this pretty much on a Pi, and you're running up in here. So it's kind of funny, like the size of containers and stuff they give. That's important. Choice of software is important. I'm very passionate. There's things I like and don't like. In the realm of GitHub or any other open source or SourceForge for any of you back then, or even Snap files, there's crappy and good and everything in between. So, and excellent software, right? And everything in between. On this, we'll try and use open source projects whenever possible. I'm a huge fan of it. We do go over some security things. Any of you that aren't familiar with the ISC squared code of ethics, it's very important. Anyone that's done any security, code of ethics is very important. So a lot of them will give it kind of out front. But with power comes responsibility. You can do things. It's like working in college in the business lab, right? Once you understand the guy that was kind of running it really didn't know, but when you started to understand communications out at work, it wasn't very hard to bring the network down. And any of you that are familiar with the ping of death, that was kind of the old joke back then. But there are 4 mandatory canons in the code. By necessity, such high levels of guidance is not intended to be a substitute for ethical judgment of the professional. So this is just, the professional should even go beyond this. This is kind of base. Code of Ethics Preamble, the safety and welfare of society and the common good, duty to our principles and to each other, requires that we adhere and be seen to adhere to the highest ethical standards of behavior. Therefore, strict adherence to this code is a condition of certification. So this is just kind of what that belong to this organization. Code of Ethics Canons, protect society, the common good, necessary public trust and confidence and the infrastructure, and act honorably, honestly, justly, responsibly, and legally, provide diligent and competent service to principals, advance and protect the profession. And I've always liked this because really computing to me is helping us and each other, and that's part of what I like Greg and kind of his vision, his intent. I don't know if any of you saw his last speech yesterday, and that's how I feel. Like, this is to make the world better. It's not to manipulate people or abuse power and stuff like that. So anyone interested in certifications on this? Everyone has a different level. LPI certifications are a great place to start. First, Linux, they've got 1 and 2. Security, ISC2, as I mentioned, they have certifications. The CISSP is kind of the Bible of security, and that covers physical security and everything. SANS org has a bunch of great classes as well as certs for anyone interested in that. And required graduation and for renewing your certs, they have to do white papers. It's a great resource for white papers. In fact, I just used one getting my own password store. I just kind of used my own, and then I used one of the white papers to look up different ones and probably what's best. Networking, CCNA, Juniper has the certifications, Cumulus, which is a Linux-based networking. They all have different certifications. The CCNA is probably the best way for any of you that are more want to get more into comms and even certified and stuff like that. Why would you want to have your own infrastructure? Kind of a general question out there. Does, by show of hands, does anyone here have not an R-chain node, but just a node running in their basement that's publicly connected to the network? We got some back there. Awesome. Right there. Yeah. Is it running like a web server, or is it just like a bastion and host for SSH, or just whatever? But I'm glad you guys are doing that, because over the last decade, everything's become centralized, and that has its issues. There's benefits of centralized compute, but there's also a lot of downsides. Again, education is fun. Ownership, control. One of my favorite quotes is Steve Wozniak, and I remember when I read this because he did not like what was going on. He says, "With the cloud, you don't own anything. You already signed it away." And Rao, I don't know if he's here, he made that comment. There's different laws in public infrastructure than there are on your own private premise on your house and stuff like that. Yeah, distributed compute's important. We already have a large distributed compute all around us. Content delivery networks in neighborhoods and homes and ISPs provide faster access to data. Even on your running your Netflix, right? They cache tons of data. You got your very localized content delivery network right there. Cloud computing versus localized home computing. Like I said, who's hosting so private cloud, who's hosting something in the public cloud right now? Whether it's a container, a node, or whatever, just something, right? Maybe you play around with it, yeah. And again, I'm not here to bash public computing. There just needs to be a balance in what people do, and I'm a fan for both, where they make sense. Like I said, maybe a blog, documentation, MediaWiki, Confluence, code ticketing, project management. Maybe some of you are hosting GitLab. Any of you coders, GitLab in there. Huge fan of it. It's nice, open source project, and you can host rather than using Bitbucket or GitHub or whatever like that, you can host it and you can still make it publicly accessible. But that comes with its challenges. Problem of the pendulum: centralized, decentralized, centralized, decentralized. It's always a swinging pendulum. Wires. Kind of going into technology. Anyone here familiar with wave division multiplexing? I kind of want to walk through the OSI model. It's a way over the last, especially the last 5 years, 10 years, The advances in manufacturing on glass has made the ability, and then also technology for wave splitting, light splitting, has vastly, orders of magnitude, increased the amount of bandwidth we can track. So it might look like they laid more strands of fiber in the ground, which they did, but they also 10x plus the amount of bandwidth they can send on it. So this just shows you anybody that aren't familiar with mux or demux, maybe some from the old analog days. Just light. You can kind of see the middle right here. You've got your different light frequencies there. You could have one fiber running multiple strands of light. CWDM wasn't, of course, DWDM wasn't good. Dense mode, you get a lot more light, and that's where we get a lot of the gains and stuff. And so there's always a need for more bandwidth. There's never enough. Fiber optics is a godsend. Communication has become a lot easier. Everything's connected. Discord, Zoom, whatever. It's cheap and it's easy. Voice has become really easy. Maybe some of you that are into development and doing communication pieces have used Twilio or Nexmo. Some of you might be familiar with GoDaddy's acquisition of Freedom Voice, where they started providing voice services so you can have your own number on there. I love Nexmo and Twilio. $1 and I've got a number and I can do all sorts of things. Send stuff out. Do I want to do it in Java? Great. Python? Great. Library, very easy to work with. We all know WebRTC. We use it every day. It's a great standard and lots of great open source tools around that. Decentralized networks demand bandwidth. Obviously, we need to increase the infrastructure we have in order to make decentralized compute, peer-to-peer network, and R-chain and blockchain, all of that work. SpaceX, rise of the satellite internet. Wireless will always be slow. Wireless has gotten better. Google Balloons, Facebook, solar plane. I don't know if anyone's here seen the Facebook solar plane, but it was one of the most bizarre videos I've ever watched. But they're trying, right? I think low orbital satellites work. SpaceX just recently launched some to do kind of a preamble to their 4,000 plus. Encourage network bandwidth. We want more municipal networks. Some of you might have your municipal networks and work with your Glenn mentioned like OpenStreet, like different ways to work with either your neighborhood or your government. We need to promote faster bandwidth. Bandwidth is fastly becoming a socioeconomic factor of trapping people in lower class due to education and ability to work as remote telecommute. Lots of talk of simulating a network build out. You can soft build and then you can publicly fund it to your so different ways. We'll see if we have time, but again, a good ideas on that. Understanding how networks work. Again, kind of different boot camps and stuff. This is going to be. I'm a big networking guy, so it's always a big part of what I do. If you aren't familiar, any of you here have used Linux bridging very much? Anyone here? Right there? Yeah. If you have not, if you are a Linux fanatic and have not used these commands, use them and learn how you can simulate very large networks, even on your laptop with 16 gig and stuff, just using command line and stuff like that. And we might talk about a little bit. Many of you are probably familiar with IP tables. EB tables is just layer 2 filtering and stuff like that, so you can do logical isolation and stuff. Suricata, some of you are probably familiar with Snort. Suricata is a multi-threaded, it's a fork from that, multi-threaded, and they actually redid actually redid a lot of stuff. So kind of started things out right. And it does, there's a slide later, but it does context filtering where I can tell what protocol it is. I think the newer version, Snort 3, will do that things. Mininet is a cool little like network building. EVE-NG, if you want very powerful network simulation to run network simulations. I don't know, Vlad might have even used it for some of the stuff he was doing. You can simulate very large networks. I'm limited to kind of 64 gigs on one of my machines at home, but if you had a very big machine, you could simulate very large. And that's just a virtualization. It will support Juniper, Brocade, Cisco, Linux, tons of different images and stuff. If you are into networking at all and simulating network environments, EVE-NG is a great project. Some of you might have used GNS3, which was really good, but EVE takes it a step bigger. And the cool thing about EVE is it's a web interface. So you can jump on and work with these things through in your own little private compute cloud just by VPNing in, or create a punch through on your firewall. I got Boson, which is the Cisco one. We're almost done with our kind of preamble to network infrastructure, just because there's a bunch, most of you, this is probably old hat, but there's a whole bunch of different people out there with different levels of knowledge. Learn from AWS or GCE. Don't reinvent the wheel. You're not going to be smarter than a guy that spent 20 years in the field building networks and stuff like that. They've seen it all. There's reasons they do things a certain way. And while I want people to move out to their own, out of the cloud and just build their own little clouds, right? Decentralize, diversify it. You want to learn from the bigs. I remember when I got into telecom like 12 years ago or whatever, all my structure, and even to names, I looked at what? Microsoft, Google, obviously Amazon wasn't that big yet in there, but I looked what they did because they had spent millions and lots of time and lots of engineer hours on it. So this just kind of shows how AWS spread out. Most of you are familiar with regional data centers and zones and stuff like that. It is a great way to get into data centers quick. Things like Omniture, Adobe, they just have a bunch of data centers, or these analytics that are killing it. They just have a bunch of data centers they have hosts in, a lot of them bare metal, and they'll just collect data, right? You can do it, Netflix, whether it's your ISP, as I told you, they'll try and push their content as close to you as possible. The same with Google, with YouTube. The closer content is to you individually, the faster it is. And that's the same with your wireless providers and stuff like that. They've done it. And they don't want the cost of the backhaul of the bandwidth either. So it's advantageous to them. Hopefully in the future, peer-to-peer networks, the intelligence within them, you'll be able to have local cache very easy, very secure with distributed compute, like our chain. Again, very common virtual private clouds. Many of you are probably familiar. Most businesses are like this. It's a lot of it, whether it's on hard or soft, it doesn't care. It's virtualized. They'll do underlay and overlay networks to run different things. Lots of you are probably familiar with this. Again, kind of the emergence of content delivery networks. I think this, as I've mentioned before, is kind of the future. Big talk with what they call micro data centers, where so you wouldn't, like you could have stuff in your house, but maybe, hey, maybe I don't have the money to have a power wall, you know, or you can create your own battery store. There's YouTube videos for that, but I don't want to manage their maintenance. You could go in a neighborhood, you know, and this could be publicly funded from your community, or you could algorithmically figure it out. Maybe some economists out there are watching this and want to get in it. Again, this kind of goes with my municipal network build out. With the net neutrality reversal, all the power goes back into monopolies and oligopolies that kind of have control of the data. just like the press did back then. They can trickle data if they want. They can give fat pipes to stuff they need. We don't have to mention Facebook here, right? There's different issues. Yeah, pushing to the dead. But so you'd have a compute. It could be a small enclosure, a large enclosure. Nice. You could have it underground, but just have it localized in the neighborhood where you could have secure access and stuff to it. But they're smaller. They're not going to be these huge clouds. Anyone here familiar with the OSI? You got a few here? This is like my favorite thing. I wish they just had a class and taught it and ripped it. This is right off, I think, maybe this one is off Wikipedia. Go to Wikipedia to get a little more in depth. It's a way of breaking out the communication layer. And a lot of you are familiar with our chain, right? So our chain's you have your transport layer here. All of us are familiar with TCP/IP. We're familiar with TCP/UDP. Right now it uses UDP. They talked about gRPC and using TCP and TLS. So that's where it sits in this space. But we do have a network there, obviously data link, frames, your encryption and stuff. But it's a way of breaking down so you can work with the application. And then you can do security controls within these different layers. So they become very important. This kind of tells you a little bit what each does. Really, if you just want a high-level view of comms, just learn this. Like I said, I've mentioned the CCNA and all that. A lot of that's just switches. Just get this, spend some time on Wikipedia, do some YouTubes. It's important to understand how this works because at each, you can optimize at each layer as well as do security checks and stuff like that. And any really good architect or developer, and it's hard, a lot of times developers don't have the time to learn this, but with everything interconnected, it's more important than ever to just understand. And believe me, like the network gods or whatever you want to call them that are doing their little magic, it isn't as hard as writing a bunch of code. I've done both, and you owe it to yourself just to spend a day and hash through these things. And you can even play with some of the tools we'll go over. Packet craft, create some packets, play around. So we have our OSI model. Let's start with the physical layer, right? You need some cables, you need some hardware, you need some gear. We live in a physical world. Where am I going to go to get that? And I was glad that one of the people here, he's like, yeah, I'm going to go grab some HPs right off eBay, right there, and build me a system. So you can usually anywhere, and there's a lot of stuff that's way overpriced. Just look around. For two-ish to 300, you can get 64 gig RAM. I've even got like 48 for like 300, but you can get like a 1U or 2U. You can look at Supermicro. You can look at there's a lot of HPs, like they're excessing these days because they're kind of end of life. They've been around for a while, but they have redundant power. They are loud, which would be the incentive to get the newer compute, like even the NUCs and the smaller units and stuff like that. But this is just an option if you want redundant. And usually for what you're doing, maybe that isn't important. Redundant power and stuff like that. And then I do mention it later, but NVMe, if you guys aren't familiar with that, that's what's in all the laptops now, the newer ones. It's not your solid state, getting 500 by 500. The NVMEs are very fast, especially for non-volatile memory. I always forget the E if it's like extended. But the Samsung Evo 960 is a great buy. I think it's like a couple $100 for the 500 gig. You can get a terabyte. I bought a good chunk of money on some, just for some my compute cloud. And you can RAID those if you want. You'll usually have to get a PCI card that fits the M2 if it's on older hardware like this. It's not going to have the proper, but you can, or if you get like an old HP Z tower for usually $400, you can get like a 4-core, 8-core for $400 to $600, and use those. But you do want to get the NVMe like I said, you can do fast stuff, fast databases, stuff like that. And some of you probably already do it, especially to do data store, stuff like that. I do cover it later, but well, we'll just go. I think it's up here pretty soon. Like I said, you use eBay. These two, and you might like them. Acme Micro is a very generic. They do mass quantities. I use them quite a bit in the past, but it's I don't know where they're. I haven't used them for a while. FS.com, if you're building out network cabling infrastructure, they're a good place to start. A lot of telecoms use them. Netbox, software managing hardware and network resources. These are just kind of a list of projects. Netbox is one by DigitalOcean. By the way, on tutorials, if you're new or getting into Linux, don't waste your time with the other ones. Just type DigitalOcean Ubuntu or DigitalOcean CentOS or whatever you're doing to look for tutorials. They're probably the best right now. Just a little shout out for all their work they've done. Rack tables, DCIM. Oh, Netbox is by them though. It's a great IPAM project, and they're keeping very focused on DCIM. So it will do rack space management. So if you had a data center, let's say some of you out there are going to buy a rack, or a couple of racks, or 3 racks, or 5 racks at not Amazon, because it's very expensive, even though they are adding rack space now. Just at your local data center. They're all over. You don't know about them. Just do a search or ask some friends that work in the tech, and they'll be all over, where you can host data for a margin of what you're going to pay for AWS and stuff like that. But Netbox is a really good project to manage IP addresses, and then you can even see your racks and where they're at. Rack tables is another pretty good one. I think the issue with that was it doesn't have split space. It might have it now. Netbox has that, where you can have overlaying different network space for overlapping. NOC project, if any of you guys have used it. Infrastructure as code. Programming Terraform is quite common. SaltStack. Has anyone here used SaltStack ever? Got one back there? Nice. Love it. Again, Puppet was the first one there. I'm a Python guy, so I like SaltStack. The irony, the guy actually that the creator, Tom Hatch, actually lives fairly close to me too. Smart guy. Chef, Ansible. These are different ways you can run a command and run it on simultaneously on 3 or 5 or 10 or 1,000. This is the way a lot of places, and in the past it was mainly Puppet, managed thousands of nodes. You can do it too. This might be a tool you want. It's so easy to set up. It will literally take you 5 minutes to get going, especially if you're using containers. Monitoring, everyone has their preference. I like Zabbix, Xenos, OpenNMS, Nagios, Prometheus, which we've used on one of the node releases for network metrics. NFDump is kind of a hidden gem. And it is, the guy used it for security. It's for doing network flows and stuff like that. It can be very advantageous, especially if you're hosting a large node cluster, compute cluster, for Archain or whatever you're doing. Anyways, very fast, written in C. Logs, Elastic Stack. You might have heard of Elk Stack at one time. Splunk, a lot of you probably worked with Splunk and stuff like that. Very handy, they have a free tier. Active passive versus simple, active checks. So on here, has anyone worked with monitoring systems with agents? I'm sure many of us have there. Has anyone worked much with active agents, or you can think of it as pull versus push, where passive, the proxy or server is reaching out and grabbing data, and that's the most common. That's kind of like with Prometheus their modes, and there's a lot of advantages to that. But then sometimes if you don't control firewalls and stuff like this, the idea of an agent on the machine collecting information and then sending it up somewhere is important because you can't get access to that. And you have to work through all the security checks, and this is a perfect. So passive checks, it depends what you're using for, but be aware active checks are very useful. The hard thing with that is you you aren't getting it. But if you can't get access to the host, you can't get access to the host, so it doesn't matter. Simple checks. You don't have an agent. You just grab stuff. Use proxies liberally to scale. Many of you are probably familiar with proxies. Just a way of mass collecting information, and then it aggregates it, bundles it, and then ships it to your master store, database, or whatever. It's a good way to scale. Data partitioning, for anyone that isn't database or DBAs, it's just a way of sharding. Like everyone's familiar with a blockchain shard. Well, it's been around forever, the idea of sharding data. So there's tons of scripts out there for different databases. Some of them do it automatically, like MongoDB and stuff like that. I'm a Postgres guy. There's a Timescale, which is a project that they're working on that does time series auto sharding, stuff like that. Some PhDs back east working on. Metrics are simple for anyone that's doing data, collecting it. Not a whole lot to them. Item ID, which is basically tied to a host or metric type, like CPU and like my host. Value decimal. Could be any value, whatever you're collecting. Timestamp. A lot of times, timestamp is just time collected, or a lot of it's time received. Like Prometheus, I grab it out at a certain time. I kind of like both. If I was to ever write my own, a lot of them just have one. I like both because sometimes, like on the active, you don't know when it was actually collected because there might be a delay if there's network connectivity breakage or anything. Timestamp will be stored in nanoseconds. For ease of consume, if any of you guys are developers, probably some of you worked with, if you've worked with graphical C3, D3JS, probably some of yours. High charts is one that I've done D3 and C3. I liked high charts better because the APIs were tight. It's very easy to take JSON and make nice flowing graphs. Getting back to hardware is cheap. I just list some more. Hardware is powerful. Again, NVMe very fast. 199. You can see the performance on there, and you're familiar with the others are about 500. For read-write. Getting IP space. This is maybe something where people aren't as familiar, and I think it should be easier. Obviously, IPv4 space is out. There is a wait list. You can, so usually you have to go to your local provider, like a local ISP or a national ISP, like AT&T, level 3 or whatever like that. But IPv6, with IPv6, there's so much space that I'd probably just get my own space, in there and use it for whatever. But this kind of lists fee schedule. It's usually like for the small, it's anywhere from like a couple $100, $250 and stuff like that. You can look on there, and it's not a lot. But again, this idea of decentralizing versus centralizing. Well, let's just click on there because I really do think this is important. I think it was like 250. So you see how they have different, like a 3x small, 250. You see this is like a /24 for IPv4 net space, a /40 for IPv6. And if anybody know how big a /40 is, you could pump up a lot of nodes on IPv6 with that. Like I said, IPv6 is a godsend for so many things on the internet. I think you'll see a lot more people having their own ranges and have them stick around, just like DNS. And again, at first DNS was hard and more expensive, but it's not that complicated what they do. Yeah, DNS, OpenSRS, AWS, for anyone out there that isn't. Storage rule number 1, and most of you probably know this, don't waste your time with other file systems, use ZFS. So many of you are probably familiar with like using a RAID card, and then I've got to make sure I have the right driver, and I got to keep that driver up to date, and I've got to make sure that it's secure because it's running this different. It's a nightmare. And ZFS, which was part of Sun Microsystems, which was acquired by Oracle, so default on Solaris, it uses that. There are some limitations on use. So it is a little harder, like it doesn't come default with Linux. They're working on BTRFS, I think OpenSUSE, working on that, but it still has some issues. Yeah, it's got a ways to go. Ceph is a cluster file system. Gluster, probably some of you are familiar with. I think Red Hat back in the day was doing that. Moose, Lizard, which are basically, but I would stick with Ceph, are some other ones that kind of use ZFS in that. And the thing is it's so easy. Like if you had, oh, I just lost my, it's so easy. Let's see if this is still up here. I mean, this just lists the commands. You see creating like a mirror is as easy. So let's say my operating system is already running and I just pop in a couple drives, right? Creating a mirror is as easy as, yeah. Here, it's easy to read on here. There's a stripe. Let's go. Yeah, you can create a data pool right here. Yeah, create a mirror like that. Let's say I want to do RAID 10. Then I'm going to do that. So it's a striped mirror. And it makes it more logical. They even rewrote like RAID 6 and all this stuff and 60. Like for adding parity, they just call it their Z. RAID Z is just like RAID 5. And then if that's with RAID Z1 is RAID 5. And then RAID Z2 is 2 parity. Like it's all logical and stuff like that. It's not kind of silly how the old was. But again, look into it. Just do a quick walkthrough. The limit with ZFS is you do go to the smallest drive. It's not like some of you might have are familiar with like Unraid or something like that, which you throw any drive and it builds this. I think Moose FS works with that and Lizard, but there's always a trade-off. But anyways, Moose CFS, FreeNAS. Some of you probably use FreeNAS. Why go grab NetApp when I can, unless I have a lot of money to spare, when I can use FreeNAS. FreeNAS, again, ZFS default. This snapshot supports easily adding in NVMEs and stuff like that. So maybe you have a bunch, let's say maybe I'm doing video and I've got 16 or 32 drives or whatever, a bunch of chassis hooked together with some expanders, and you want to speed up the drive with NVMe for quick read-write. It supports that in there, and as well as compression, dedupe. And I don't think NetApp even looks that good. The interface, yeah, it looks a little weird, but who cares, right? It's like that was the one reason I shifted to Google. Yeah, we have a question back there. I don't at all, because it's simple and there should be enough. And I think we would I would just public specs to the community. Obviously, I like to support, obviously with all these open source, they need a financial stream. Support them. I donate. Anybody here that's used Let's Encrypt, donate to them. Like they literally, anyone that's done certificates, it was a nightmare. It was a joke, and you had all these little companies kind of coming in. I mean, and people were making big money, and they weren't doing a whole lot as far as complexity. And so I donate to these projects. And so whether it's buy or if you don't buy, I don't see advantage. I looked at some of their stuff, and I'm like, I can just build it better and cheaper. But it's a great option, right? And I encourage people that don't want to mess, go to them. Like it's going to a good cause. It's going to go to fund the project. So I don't see a bad issue in that. But thanks for pointing that out. I think it's, like I said, I think they're a great project. I can't remember on that if it was a little smaller. I can't remember how huge it went. But it depends what you're trying to do. And obviously they're trying to fit a space. But yeah, great project. Kind of on comm stuff, some of you are probably familiar or not familiar with jumbo frames. You probably want to set that if you have like shared disk, and so go into your switching equipment. Most gear will support it now. Yeah. Oh, yeah. Speaking to the mic. Sorry about that. I'm not as
Sure.
Nash and Greg are awesome with that. I still need.
Since we're talking about storage, seems to be a lot of debate in the community about the maximum size of a drive in, say, like a RAID 5 or RAID 6 setup in terms of being able to recover a failure, given like read-write errors on a drive. What are your thoughts on that in terms of like a maximum single unit size in a RAID array?
My rule with RAID is never use RAID 5 or RAID 6. I do RAID 10. Do it. It's fast. You aren't going to end up with all these issues. You might get a little more performance, but a lot of times you're going to lose it in write abilities. But it does depend. There are cases for it if it's a heavy read type thing. But like you said, the rebuild times are insane. Like I don't want to risk 3 days out. I guess how risky do you want to be? But good question there. My rule of thumb is unless I really have a good reason, do RAID 10, right? So you have parity for each drive mirrored, and then you have those stripes so you can get the throughput. Anyone that's not familiar with RAID. And so many, like in the past, the joke, well, it was true. You'd hire some consultant, some storage consultant to come out, and because your Oracle or anything, I mean, these are large applications, weren't running right, and they would just go in there, and what was the answer? RAID 10. Like dump your RAID 5, 6. Storage is fairly cheap. You can distribute it. Like I said, mentioned Ceph before, and there's really no reason to use those. That's just my opinion. Like I said, unless you have a case, and there is, like heavy reads, definitely. But I try and avoid them. Okay, so now we're jumping back in. Some of you are probably excited on this. Using a firewall to DMZ and mitigate rest. And this is what I spent a lot of time in. Again, back to the OSI model. Everyone that remember that, how you have your different layers. And you might have saw the tag I put on, sooner is better than later. And Ed brought up a good comment in the communications, if anyone was in there, about denial of service attacks and security and stuff like that. Obviously, you want to start it sooner, and firewalls are the easiest way to do this. Most of us probably use VPNs. Again, leave the whole world out. There's millions, even billions of IPs out there. Let's only isolate it down to a handful. You've mitigated your risks a mass amounts. Like I could harden my machine as much as possible, but it's a lot easier, cheaper, and everything, and more secure just to isolate the network only for those that have a need to do that. Linksys, DMZ, not really true DMZ. Maybe some use that. It's a little, most idea of a DMZ, and this goes into hardening, like some of you that mentioned, hey, I have a bunch of boxes, I want to hook them up. Public internet, especially stuff that if you're not sure, just totally isolate it, right? So they'll have an idea of security zones, and a lot of times that's an interface or if VLANs if you're logically partitioning. But you want to keep the experience in the DMZ. You don't want it crawling back into another network or back into your own network. You want to isolate it, in there. I remember when I first started doing firewalls, they called them burbs, right? So you just isolate stuff. Linksys, this gets into IP tables, EB tables, great way of isolation. OpenBSD, any of your hardcore secure guys, the line-by-line audited and stuff like that. Obviously, that's still used a lot because it is probably best secure. FreeBSD, which you're probably familiar with Pfsense. Anyone here familiar with Pfsense? Got 1, 2, and I was going to demo little parts of it. Spend some time, go home. This is shout out, Pfsense, love them. But it's a BSD based, and again, a lot of networking use BSD as their underlying system. It's very fast. There's CalML. If you just type CalML BSD, they have some really good BSD optimizations. I don't know if they're relevant now, if they've kept them up, but in the past they're really good. But Linux kernel used to not be that well, or their packet filter. Some of you are probably familiar with IP chains. They went to net filter and IP tables, but it wasn't always the best. PF and like BSD, but OpenBSD, check it out. It uses all the best. If you load that up, you can even load it in a VM. Just play around with it. It will give you all the good parts. They make adding modules on very easy. You don't have to go out and pay money for the Palo Alto or whatever you want to use. It's a great project, so shout out to them. And that was just like a little, like you can go small anywhere from here. Obviously, you're going to be limited with throughput. But here's just like a little, I think this is like 150 or something like that. And you get some memory. So under 200, you've got your own little, and then you can set each, you can logically do it with Pfsense and network gear. But with these, you could easily just plug in and have a different interface. So obviously this would be like your WAN port. Let's say, hey, I'm running like management off this port. And then I'm going to use this port for public stuff. It's kind of like my dev network. And again, on firewall rules, you will not allow, you'll allow certain ports in, but you will contain them in that security zone. I can do the other one for maybe hosted stuff like Confluence or MediaWiki or GitLab or whatever. That's you kind of split things into security zones. And like I said, if you use VLANs, you can split everything up. And if you use IP tables, EB tables, and do it all in one box, you can easily do it all soft filtering, logical partition that way. Like I said, I mentioned these tools, just a couple little commands. You probably can't read them very well, but yeah. AF packet, yeah, OpenVOS, some of you guys are probably familiar with that, Metasploit. I mentioned them later. Security scanning tools, if you don't use these, write them down. Kali Linux, I kind of have at the end, kind of these tools. They're kind of hacker vulnerability test tools, you know. Scapy, cool little Python library. Yeah. Again, kind of into multi-tenancy. Obviously, we do this. We have done it. People that have a hard idea with multi-tenancy, we do it every day. A lot of times people bring the example of your house, right? I've got my house, I've got my family, or whoever, people I trust. Let's say I open it up to a boarding house, and a good idea is a hotel. So it's multi-tenancy. I now need to start putting locks on other pieces, on the doors to each room because of that. And this is cloud compute. There's different ways of doing it. We've been doing isolation methods logically, database, same thing. Cryptography is special, obviously. It's a really awesome way to isolate stuff. Kind of getting into IDS type stuff. Fail2ban, you can write your own pretty easy, looking at a log and write a command to IB tables. And again, sorry I'm focusing on Linux, but that's what I know the best, and that's what I like the best. And you could do this with Windows or whatever. They'll automatically, like for Apache logs, like I'm sure like any WordPress hosting stuff, they'll use this, but they'll just automatically look for certain patterns, and then kind of like a host intrusion detection, or I guess service intrusion detection. We'll look for different things and then block based on that. Anyway, something to look up. Network packet flow, if you guys aren't familiar, this kind of goes with the OSI model. Just spend some time and go through the NetFilter packet flow. This might even be off Wikipedia or something, or off their, I think this is off their site. Understand the difference between like a forwarding, input, output. You might have heard more comm terms, egress, ingress. Again, you can see the OSI model in here, the way it works. Application layer, protocol layer, network layer, link layer. And you can do isolation on each one of those layers. Using Suricata or Snort to do IDS, IPS. Intrusion detection systems, many people are familiar with that. Intrusion prevention is just like an active trigger. So you have an event, let's say I'm sending some malicious packet. It's the IDS, you just see it, log it, send alert. Intrusion prevention will see that. It triggers an action. That action goes and does something, which is usually just put it in a block list. APIs built around it. Snort rules. This is, yeah, if you aren't familiar, this Snort rules, Suricata does the same thing. Like I said, oh, here's the Suricata rules. Let's see. Anyways, Yeah, this shows you a nice little kind of how to write the rules. Just source dest is the same way of breaking up the different layers, but you'll look for information in the payload. Obviously, if it's encrypted, you can't read it, but if it's decrypted, you can read it. Like I said before, Suricata is the best. Just use it. I don't know, Snort 3 might be as good or better, but multi-threaded, like I said, Suri is context protocol aware. So it can tell, not just, because remember, the port is not the protocol. I could be talking HTTP on an alt port, which is another thing. If you do have a Bastion box or ever, I recommend using an alternative port for management. If you do, it's just another way. Like you could firewall it too, but just another way to secure it. This is where NFQ, IPF, you can write your own rules with Suricata. And you can see here that it's pretty, this shows you how to build it. There's a little on AF packet versus NFQ. AF packet, I think, is more for passive monitoring and stuff like that when you mainly use it. NFQ is if you want to do like an active queue. So IP tables, you basically forward packets to NFQ. So this shows you a rule how to use Suricata and NFQ and do inline filtering. And again, in Pfsense, you'll be able to enable this or disable this, whichever you want to do. There is a performance hit. And because sometimes, let's say I have a slow box, if you're doing NFQ, it's going to have to do those snort rules and checks, and it might take a while, nanoseconds or whatever like that. But there might be a delay that impacts performance. This shows you how easy it is for input, output. So let's show you TCP. Obviously, again, back to OSI model. We've got TCP up here. Everybody's familiar with port 80. You can probably throw port 443. But Suricata could look at that data. A lot of people will terminate, like let's say you're doing a web host, a lot of people will terminate HTTPS on a proxy. Like if you guys haven't used Nginx reverse proxy, or another great project is OpenResty. It's basically Nginx with Lua add-ons, and it's actually nice for developers because you can actually go in. So you're probably familiar with F5s, or they'll call them application delivery controllers, but you can go in and modify HTTP headers and either up security or different things, or you can mangle payloads for your database. Okay. Yeah, so check out OpenResty, Lua. Lua is fast. Any of you AI fans, Torch uses Lua. Like I said, with RESTful or PostgreSQL, and I didn't think of that. Like I've used this project called Postgres, basically a drop-in boilerplate, and everyone familiar with Postgres knows it has row-level security. So like a year or two ago, they added row layer security in. And so you can do row layer security, and Postgres is a way of just easily adding. It's written in Haskell. We have a lot of Haskell developers. But let's see, yeah. Okay, so has everyone here, where was I? Has everyone here, yeah, PostgreSQL, if anyone's not familiar with that, that's Facebook, their protocol they use to do a lot of web query languages, stuff like that. Network flows using NFDump. We already kind of went over that. Like I said, there's a lot of great commercial products, but I'm just kind of highlighting the open source projects I like. Default Docker, firewall, containers. Okay, this was just kind of like with security. Anyone that isn't familiar, so inbound, drop only. Now, it used to not be default, but now it's default for forward to drop all packets. It used to not be. And the rule is always enable a firewall. It still irks me with Ubuntu that they don't, by default, enable a firewall. I use Red Hat, CentOS a lot of the financial institutions, and use it. And any secure sensitive information will use it, and I don't know why Ubuntu. So maybe if they hear that, I wish they would just enable it by default. It's kind of silly. But again, I love Ubuntu. I love Debian. Stateful firewalls, new, established, related. A lot of times you allow connections out. So before, firewalls used to not have session tracking. And again, this goes to our OSL. Now with session tracking, they can. I guess we really don't. Let's see. There's NFQ. Oh, what am I doing? Yeah, hypervisors. Dang. Those containers. Any questions? Sorry, I kind of skipped through. I want to talk about hypervisors. Has everyone here used Docker? We got started a little late, so I'll take a little time. Has anyone over here used Docker or anything like that? We obviously use it. It's again another way of isolating, logically isolating stuff without the overhead you used to have with hypervisors. And again, I love KVM. There's still a place, but it is heavy. Has anyone here used LXD before or LXC? It's just another containerization. Use it. Again, 5 minutes will take you to get started. It's a little more different approach, but that's kind of the Debian stuff. It's an extension of Linux containers. And it, by default, does things persistent. It's a little heavier and not broken out as much as Docker, but it's a lot easier to work with. Anyways, here's some more tools. As I mentioned, Kali and SpamHost. We'll do, again, with Ed brought up, we'll profile probably layer 3 and layer 4 behavior and whether they do something bad on the blockchain or not, or on the R-node communication protocol. We'll block them before if we see bad pattern. And sorry, well, maybe they can give me like 5 minutes. Any questions and stuff on that? On anything? Yeah, Mike. What? Yeah, right there, right? He's got the mic. Thank you. Hey, thank you.
Any recommendation for running R-Chain node? Any hardware recommendation or some stack? So here's my suggestion for that. Probably you can answer. If you can write a post or something like that to list out, what we need to set up a R-Chain node primarily with more secure way. I think what you have described, it's amazing. I think we need some of the things. Basically, what I need a cookie cutter sort of thing, give me 10 items I need, and then and then just go and run with that.
Yeah, no, perfect. Thanks, Nevni. Yeah, we will be writing this. If there's other people in the community that want to have input into this, I'd love it to be an open doc that maybe I sketch it out and the other people put it in, because you do want it. Again, Greg and I'm the same thing. The collective is always better than the one and stuff like that, especially in long term. That wasn't one of my, but yeah, we'll definitely do a write-up. And then I would even like to do like recommended kind of more cut to date, so you'd upgrade it every quarter or whatever, because prices go up and down and stuff like that. And you want to maximize, I'm a very businessy, you want to maximize your cost benefit on that, because hardware can get expensive and you can waste a lot of money. But yeah, that's it. Any other questions or? Yeah, feel free. Again, Jeremy at Pyrofex. Feel free. Everyone knows, like on Discord, like I might be working on something, but let me know if you have questions. I'm more than glad to do some more, like I said, videos to get people working and going if you need help getting up. And thanks again for your help. You guys have been great. Oh, one more thing. Well, before you guys can go or whatever, has anyone here used Proxmox before? So check out Proxmox Ve. It's not very well known. It's Debian based, but it's out of Austria. But it is awesome, and it's a virtualization platform. A lot of you use Virt Manager, stuff like that, but just check it out. I was going to demo it. But that to get on your node, I'll put it on my write-up, is the easiest way to get going, because it gives you an interface to work with. So.